So now let us learn and equals to. To understand this and equals to, you have to first of all understand this bitwise and. Okay, so let us understand this bitwise and. What I'm going to do is I'm going to write a print 9 and 3. Okay, guess the output. Okay, it will be, I think, 1. Okay, so here is the output 1. Now let us figure out how this 1 is here. Okay, now binary of this 9 is 1 0 0 and 1. Okay, how I have calculated this is really simple, right? This is 1 or 2 to the power 0 into 1 is equals to 1. Okay, similarly here this one is going to be 2 to the power 1 into 0 is equals to 0, and this one is 2 to the power 2 into 0 is equals to 0, and here this guy 2 to the power 3, okay, into 1 is equals to 8. So if you add all these value 8 0 0 and 1, you will get a 9. So you can see here this was my digit in decimal, and here this is in binary. Okay, so I'm going to calculate the binary of 3 as well. So it is 1 and 1. If you check it, 2 to the power 0 into 1 is equals to 1, and 2 to the power 1 into 1 is equals to 2. 2 plus 1 is equals to 3. So here is the binary value of our decimal value 3. Okay, now this is in base. Now let us use a AND. Now AND is evaluated 1 and 1 is equals to 1, and 0 and 1 is equals to 0. Okay, now to be 1 here we need both these value to be 1. Okay, if one of the value is 0, we will get only 0. Okay, now you can see this is also 0 and this is also 0, so rest of all the values are 0. And if I calculate this one, 2 to the power 0 into 1 is equals to 1. Okay, and for these if you calculate 2 to the power 1 into 0 is equals to 0, 2 to the power 2 into 0 is equals to 0, so everything is 0 here after this. Okay, so in this way we are getting 1 here. Okay, fine, don't worry, we will discuss how to calculate binary in greater detail. Till now if you don't know, you can use your calculator. Okay, so I'm going to use my calculator here. See my calculator, now you can see 9, this is in decimal, and if I click on binary you can see my decimal values, sorry, 9 in my binary 1001, and back to decimal and write 3 here and convert it, so 1 1. Okay, I think this is really clear how this AND operator works. So if I say x is equals to 9 here and use augmented operator here is equals to 3 and print this value x, I will get a same result 1. Okay, I think this is also really easy to do it. Okay, similarly we have other augmented operators like not equals to, and then we have, actually it is bitwise OR, which is a pipe symbol, and bitwise OR equals to, we have exponential x OR equals to, right, we have shift equals to, and we have right shift equals to. Okay, so once we discuss OR, bitwise OR, exclusive OR and shift operators, then we are going to discuss augmented operators again. So let us understand bitwise operator so that we can understand assignment operators better. In this series we are going to first discuss OR operator, or to be precise I will be using a bitwise operator, and it is represented by a pipe symbol. Now where you will find this symbol, you can see in your keyboard just above the enter key there is a slash. If you keep your shift key pressed and press slash, then you will find this is the pipe symbol. Okay, or pipe symbol, it will be typed on the screen, right? So now let us see how this pipe symbol works. So first of all, I'm going to print the binary of some values. To print this, just I will be using a string formatting. Soon you will find how to print or how to format a string very soon, but for this bear with me. Just write format and let's have a 9. Okay, now let us try to print this value, and straight away you are going to see 1001. Okay, and I told you how to do it. Now let us try to find out the binary of this value, and this is 9. Now what you need to do, you have to keep on dividing your what you need to do to calculate the binary of 9 is we need to divide your number continuously by 2 and record the quotient and remainder. Okay, so it 2 divided by 9, okay, we are getting how much? Okay, so it goes 4 times and remainder is 1. Okay, and then again divide it by 2, it's 2 and we get 0 this time. Okay, and do one more time, and this time only one time and 0 is remainder. Okay, to go from here to Dept, and in this way you will get 1 0 0 and 1, because after when you divide it by 2 you will get a 0 here and 1 as a remainder. Okay, so till 0 you have to keep on dividing, and from down to top you have to record the values. So in this way you will get 1001. Hope you got how to calculate binary of any number. Okay, now what we need to do is let us get rid of all this because we do not want this anymore. Now let us write one more, and here this time I will be using a 13, and then we are going to calculate how bitwise operator works. Okay, now let us print. Okay, let's first print the binary value and then we will see the binary value of that number. Okay, so 9 or 13 is equals to, and let us execute this program and see here. So you are getting 13 back. Okay, so the value of 9 and 9 bitwise 13 is 13. Now let us see how it is, because let us do some calculation here, and bear with me because I will be using mouse to draw 1 or 1 is equals to 1. Okay, so if you have used 0 or 1, it will give you 1. Okay, 1 0 and 0 is equals to 1, and 0 or okay, 1 is equals to again 1. Only 0 or 0 gives you 0. So in this way, so here 1 and 1 you get a 1. Okay, 0 and 0 you get a 0, and 0 and 1 you get a 1, and 1 and 1 you get a 1. So now you can see result is very obvious. The binary of 13 is 1011, and the result we are getting is 1101. Okay, let us do it for another number. Let's, in this place we are going to get a 3 here, and this time 3 here, so that let us do some more calculation to understand bitwise or better. Okay, let us execute it. So now here we have these number. Okay, so binary equivalent for 9 is 1001. let us write 1001, and binary of 3 is 0011. Okay, now let us calculate here. Now 1 and 1 is equals to 1, and 1 and 1 is equals to 1, and 0 is equals to 0, and finally 1. Okay, so now let us calculate the equivalent of this number. Okay, so what I am going to do, I am going to just print this here and write 11 here. So let us see, I must be getting 1011 here. Okay, for this number, and let's say binary of 11. Okay, let's run this. I'm getting error. Let's run this now. Now you can see binary of this number is 1011. Okay, you can see 1011. So this proves that how binary operator works. Okay, hope you got it. 1 and 1 is equals to 1, 0 1 1, 0 0 0, and 0 1 1. Okay, basic rule. Let's recapitulate the rules. That is 1 plus 1, actually 1 plus 1 is equals to 1. Plus represents the OR operator, or I can simply replace it by the pipe symbol. You can say 1 OR is equals to 1, and 0 or 1 is equals to 1, and 1 or 0 is equals to 1, and only 0 or 0 is equals to 0. So first of all, what we did is to calculate bitwise OR. First of all, we have calculated binary of 9, and then we have written binary of 3, and then we have performed OR operator on individual bits, so that we get the final result. Hope this will be understood by you. Now let us learn augmented operator with the bitwise or equals to. Okay, now suppose we have x is equals to 9 and y is equals to 3, and what we are going to do is x or is equals to 3. Okay, now let us print the value of x at the end. Let's print this x. Now what I am expecting is the same answer, that I should be getting 11 here. Okay, so I must write value of x. Let's run this. Fantastic. Okay, so this proves how this assignment operator works, right? Okay, now let us understand exclusive OR. Okay, so now how exclusive OR is represented. First of all, keep your shift key pressed and press 6 key simultaneously. This will create a caret sign, or this is called exclusive OR. And now let us find out how this thing works. Okay, let us now find out what will be the output of exclusive OR. Okay, now how to find out the exclusive OR? The exclusive OR, 0 and 1 is equals to 1. Okay, if both the bits are different, whether it is 0 or 1, 1 or 0, it will give you 1. And if both the bits are equal, whether it is 0 or whether both are 1, then it will give you 0. Okay, so 0 0 and 0, 1 and 1 0, 1 and 1 0, 0 0 0. Okay, so it should give you 1000, and decimal of 1000 is 8. Let us verify this. Print x exclusive OR, and then okay, it should be how much, 3 exclusive OR, and then it should be, I think it is 11. And let us try to print this. Okay, I'm getting 8, so that says that it is the correct calculation. And let us try to find out the value of this 8 in binary. Here, let me copy this one and replace 9 with 8, and let's say 8 binary is like this. Okay, and let us execute this program and see. So 8 binary is, you can say 1000, and 1000 you can get, you can see. So here is the calculation how you can perform exclusive OR. Okay, and let us see how to do it. in assignment operator. Or we have y is equals to 3, that means you can see the value of y is in binary is 0 0 1 1, and we have y exclusive or, and then we have this time we have 11, and let's try to print this y here. Okay, and see the result whether it is again 8. Okay, now you can see still I'm getting 8 in the first line. Okay, so this proves that augmented operator working, right? So let us conclude this video here only, and next we are going to learn what are left and right shift operator. Also we are going to discuss other operators, right? So goodbye for today, thank you for listening, and bye bye.